classification can also be studied on the basis of inoculation methods. So there are basic two inoculation methods. One is bulk starter and the second is direct wet set cultures. Bulk starter itself means it is done in bulk. So but because of the large amount and large volume, it requires preparation at the dairy plant. But direct wet set cultures can be done ex situ, that is away from the plant in the laboratory also, and they do not require preparation at the dairy plant. So what is there in bulk starter preparation? Here we are using freeze dried, frozen or liquid cultures, and the procedure includes selection of culture, which is either done by purchasing from the culture manufacturer or it is used from the company stock itself. The storage is generally done in freezer or refrigerator. Then the propagation of mother culture is done. Intermediate cultures and bulk starter cultures is done regularly, and then this is ready to be used or inoculated in the fermentation vessel. If we see wet set cultures, the concentrated freeze dried or concentrated frozen cultures are generally used and preserved, and the procedure includes again selection of the culture either by purchasing from the culture manufacturer or from the company stock. It is also stored in freezer, and then it is used to inoculate fermentation vessel directly whenever required. So the further discussion will be carried on by my colleague Mrs. Hiral Shah.
As we have already seen that there are several factors which affects fermentation process. Now we will see one by one different steps which is necessary to consider while starting the fermentation process. I will start with temperature, as it is the one of the most important regulatory factor. Temperature, according to temperature range, we have already divided it into two different groups: mesophilic starter cultures and thermophilic starter cultures. You can see that according to the temperature, the majority of lactic acid starters are belonging to either mesophilic group or thermophilic group. Lactic starters such as lactobacillus subspecies lactis as well as subspecies cremoris grow optimally at 27 to 32 Celsius, whilst on other hand Staphylococcus thermophilus and some lactobacilli grow best at 37 to 42 centigrade temperature range. But there is a variation for Leuconostocs. They have their own optimal temperature between 20 to 30 Celsius, which indicate that fermentation should be done at a particular temperature range, then only the results can be optimum. Now second most important factor is pH. Lactic acid bacteria produce lactic acid at the level of more than 10% of their weight per minute after their growth in milk. At thus pH of milk is lower. Extreme acidic pH could be detrimental for the viability of LAB. Hence, it should necessary to control the pH of milk during the propagation of starters which is very important. Both externally and internal pH controlled media are used normally in the preparation of bulk starters. When we are talking about multiple starters or mixed starters, we should consider starter compatibility. What is starter compatibility? Mixed starters have been used for the preparation of several fermented dairy products. The main objective of using a mixture of starters in mixed culture is that even if one starter becomes infected by a specific bacteriophage, the other strains would be unaffected and able to culture to produce adequate acid and bulk culture preparation. It is the same thing may be good for the antibiotic resistance ones. Now, not only the pH, temperature or strain compatibility, but the medium which is you are using for fermentation should also be fulfilling the requirement for the growth of bacteria which you have selected as a starter culture. Or the medium used generally for the cultivation of LAB are quite complex. The mostly widely used growth media are like MRS, M17, lactic and Alicur or Alicur media. Although Alicur media is one of the choice and used routinely, but M17 is also an excellent growth medium and is extensively used for the growth of lactococci. Several plating media are also available, which is described for the differentiation of different species of lactococci. Another media on which lactococci can be differentiated easily is known in an abbreviation as FSDA, which differentiate fast and slow growing lactococci. Certain inhibitory substances which can interfere during the fermentation process. There is a presence of residues of some antibiotics, sanitizers in milk, as well as the production of antibiotic-like substance, bacteriocin, by certain wide strains of Lactococcus, lactis, subspecies lactis, and other lactic culture in raw milk. Bacteriophages, as you have already understood that it can interfere with the process. It causes slow acid production by lactic acid bacteria in the commercial environment. The most promising solution of the problem could be replacing the phage sensitive strain with a phage resistant ones. Incubation period. Whenever we are talking about any fermentation, and especially for the fermentation of starter culture, we should be precise for incubation time. Normally, for starter culture preparation, 16 to 24 hours incubation is adequate for the maximal growth of this organism at their optimal temperature and other conditions. But for storage, it is differ. You can store the ripened starters for about 18 hours at a low temperature does not appear to affect their activity. Heat treatment of milk. Proper sterilization and heat treatment is desirable for good quality of starter cultures. Adequate heat treatment given for milk drive out the dissolved oxygen, bring about formation of sulphydryl compounds that are growth factors. It destruction of inhibitory substances naturally present in the milk, and killing of antagonistic bacteria is also advantageous. Degree of aeration. Proper aeration, agitation, and the sulfur culture usually depress the activity of lactic acid bacteria. So, if possible, a reduced level of oxygen tension is favorable for the initiation of growth, as it affords the energy for the growth by a mechanism somewhat more efficiently than the lactic acid fermentation process. Storage condition. Not only the process of fermentation, but when you are storing the product, it should be also in a correct manner, then only it will give your proper starter cultures. It is desirable not to store the mature cultures in presence of acid that they have produced during growth. Storage under these conditions will result into a cellular injuries and promote the loss of plasmids, which may increase the proportion of slow cells in the population. However, even if you want to store the mature cells, you can store it, but you should follow certain rules, like you should store it at 2 to 5 centigrade, either in a milk with addition of CaCO3 to neutralize the pH, or in stabs of selective media. Cultures can also frozen and stored at minus 40 Celsius or below in the freeze drying conditions. Now, effect of CO2. Complete removal of carbon dioxide from a medium results in extended lag phase until the bacteria have slowly producing sufficient carbon dioxide to sustain the normal growth. Normally, it is observed that for most of the lactic acid bacteria, the optimal initial concentration of CO2 varies from 0.2 to 2.3% by volume, while in case of skimmed milk, it may contain only 0.3 to 0.5% of CO2. This may account for a prolonged lag phase of the given starter culture. Now, how you will prepare the starter culture? The preparation of a starter culture, especially for good quality preparation, one should consider certain factors such as selection of a milk. Normal, clean, and free from inhibitory substances should be selected. The abnormal milk, mastitis milk, and milk with unusual high lipolytic activities and low in total solids should be avoided. Heat treatment of milk. Milk should be treated or heated properly. A minimum 71.1 centigrade for 30 minutes are required. The steaming and boiling of milk for 30 to 60 minutes for mother culture is preferred. Whatever utensils or containers you are using should be thoroughly cleaned and sterilized by steaming for at least 30 minutes at 100 Celsius. Level of inoculum means a proper inoculum size for starting a starter culture. Fermentation process, here 0.5 to 2% inoculum is optimum for maximum level of growth rate. It shows an large scale production of LAB. This flow charts indicates how in how many steps the fermentation process is going on and how you can store it. As the first diagram indicates that raw material is a reconstituent, mix it properly. Then a strainer is used for staining purpose. After sterilization, fermentation is going on for should be done for a proper duration. And after cooling, you can store it in a cold storage with temperature round about 5 to 15 centigrade. After fermentation, how will you maintain and preserve the starter cultures? In general, for dairy starter cultures may be preserved by one of the following methods. Liquid starters or second is dried starters, which is an alternative method and widely used for commercial purposes also. It has also different varieties like vacuum drying, which is an old method, then freeze drying or lyophilization, which is normally used in laboratory for preservation of different starter cultures, but for commercial purpose, freeze drying of a concentrated culture is more beneficial and used. Next, frozen starters. Frozen starters can also be preserved in a frozen form, and such cultures are produced by two different routes: deep or sub-zero freezing, that is minus 30 to minus 80 Celsius, or you can use a liquid nitrogen, means ultra low temperature freezing, that is minus 196 centigrade. Now on starter cultures, fermentation, how you will prepare it, how you will maintain it, but you should also know certain problems which you can face during the starter culture fermentation and preservation. We will see one by one. One and most important thing is that slow acid production. When lactic acid is generated at much slower rate than the normal expected, or in extreme cases not or at all, this slow acid production or not at all production by starters can lead to a complete product failure or a poor quality product showing increased incidence of spoilage and pathogenic problem. So you can say that acid production should be at optimal rate. Slow or fast acid production can reduce your quality of starter cultures. Second, bacteriophage. This normally originating from the raw water milk can attack the starter culture organisms during the starter production and use. This is by far the most important cause of starter culture failure. So it is preferable to use multiple or mixed starter cultures. It is particularly important point in large scale semi-continuous cheese manufacturing process. Antibiotic residues in milk. Antibiotics, if present in milk used as a raw material for starter culture fermentation, it can kill or inhibit starter culture organisms or destroy the balance between the organism in a mixed starters. Normally antibiotics enter into milk when other injection of antibiotics are used to treat mastitis. The problem has been solved by the use of routine quality control checks on milk for the presence of antibiotic. In United countries and in other European countries, financial penalties are imposed on farmers producing milk containing antibiotics. Inadequate rinsing of equipments. If equipment not rinsed adequately after the use of sanitizer, starters can be affected. Starter activity can be inhibited by the presence of sanitizer residues in the milk. Presence of agglutinins. Agglutinins are antibodies that cause bacterial cells to clump together. They can be naturally occurring in milk and can cause starter cultures to clump together, results in a slow acid production. That is again a problem. Then instability of functional plasmids. Lactic acid bacteria contain plasmids that are responsible for determining a number of important starters properties. That means lactose metabolism, proteinase production, bacteriophage resistance, and the production of polymers. Once plasmid can be lost during the subculturing stages employed in starter production, results in slow acid production or other defects. We should also consider the nutritive value and health benefits of starter culture products, in which we'll start with proteolysis in milk. The biological value of protein increases significantly from a value of 85.4 to 90% due to breakdown of protein into peptones, peptides, and amino acids. The contents of essential amino acids such as leucine, isoleucine, methionine, tyrosine, tryptophan, etc. increases considerably, which offers special advantages not only for healthy people but also for a particularly the physically weak persons. Hydrolysis of lactose. Approximately 45 to 50% lactose, 16 to 20% galactose, 0.6 to 0.8% glucose are obtained from lactose hydrolysis on the basis of an average 5% lactose in milk. Lactose hydrolysis takes place due to beta galactosidase production by a lactic acid bacteria. Lipolysis reduces the size of fat globules, which become digestible. The production of free fatty acid as a consequence